first inequality. We're going to graph y is greater than 3/4 x minus 2. To graph any inequality, I take what I know about graphing linear equations already, and whenever I have something that's in slope-intercept form, right, y equals mx plus b, I know what to do with that. So I see something over here in my inequality that's very similar. So I could get started here by graphing what is called a boundary line based off of this form. So to do that, my y-intercept is going to be -2. My slope would be 3/4, so from -2 I'm going to go up 3/4, plot a secondary point. Got my 2 points to determine my line, obviously, and now I turn my attention back to the inequality symbol we're using. Since it's just greater than and not greater than or equal to, I'm going to make this line a dashed line. So what that says to me is that, okay, if I pick any point on this line right here, and I plug back in over here, well, that's going to make that statement untrue. So the idea is, by making this dashed, I'm not actually including those points now. Since it is greater than, what I'm going to do, I'm going to look at how this line splits up the y-axis. Splits up the y-axis right here at this point. So this is my high side, this is my low side of the y-axis. Whenever it's greater than, what I want to do is I want to shade to the high side of the y-axis. Since that falls over here on this side of the line, I'll do my shading basically above the line. And what this is creating what is known as the solution region for this inequality, meaning I could take any point I want from the shaded region up here, plug that point back into the inequality, and I would get a true statement back. Right, another one for us to try, x minus 2y greater than or equal to 6. Just like the last one, if I use slope-intercept form, it's kind of my basis here to graph my line. It would be nice if this inequality was in that form, or modeled that form, so I should probably take that inequality and solve for y. Solving for y, I'm going to take my x, subtract over. Going to be left with -2y greater than or equal to, rearrange my term just a little bit, got -x plus 6 here. Now getting the y by itself, divide everything by -2. Because I'm dividing by the negative and this is an inequality, I do have to flip that symbol. So beware. Y is going to be less than or equal to. Got a -1 is a coefficient there on x, so it's -1 divided by -2, positive 1/2 x. And then 6 divided by -2, get -3. So using slope-intercept form as my inspiration to try to graph what I have as this result over here. I'm going to go to -3 on the y-axis first, because that's my y-intercept. I'm going to use my slope to plot out a secondary point. So from this point I go up 1/2. I'm going to be mindful of the kind of symbol I'm working with here, less than or equal to. Since it's got the potential to be equal to, I'll make this a solid line. Now I'm going to pay attention to how this line divides up the y-axis. Divides up the y-axis right here at this point. So here's my high side, here's my low side. Because it's less than or equal to, I'm going to shade to the low side. So that shading would be down here to create my solution region. All right, so remember our motivation here. trying to take the inequality we have, make it resemble slope-intercept form. So even though this is an inequality here, if it was an equation, hopefully it'd be pretty straightforward. It's just going to be a situation where we cross multiply. But that can work here with the inequality as well. Because what I'm cross multiplying anyway, these key values of 2 and 3 that are being cross multiplied across the inequality are both positive. So it's not flipping any symbols around. So if I take, say, this 3 here, multiply this quantity of x plus 2, do have to understand it is a quantity of x plus 2, so that 3 will get distributed through. I'll have that on the left side of the inequality. On the right side, I'll take 2 times this quantity of y minus 1. Once again, need the parentheses, that is significant. Now do some distributing, so 3 gets multiplied through here. We have 3x plus 6. That's greater than 2 gets multiplied through here, get 2y minus 2. So I'm solving for y. As I solve for y, I could add the 2 over here. That's 3x plus 8 greater than 2y. Now divide everything by 2. Well, dividing everything by 2, I've got 3 divided by 2 here. That's 3 halves x. Plus 8 divided by 2, 4, all greater than y. And that's okay. But for coloring purposes here in just a moment, it might be nice to turn this around a little bit. Since it's an inequality, be consistent with your symbols as you turn them around. If I'm going to bring y over here, then I need to flip this symbol around. It's going to be y is less than 3 halves x plus 4 as a result. And now I can go up on the y-axis to my y-intercept of 4, plot that point. From that point, I can use my slope and travel up 3 over 2. That takes me off this graph. So what I'm going to do is I'm going to do the exact opposite. I'm going to go down 3 over 2, plot a secondary point. What kind of line are we dealing with here? Is it going to be solid or dashed? It's going to be dashed, right? There's no equals bar there. So we don't actually want to include the points that are on the line. This line divides up the y-axis right here at this point into high part of the y-axis, low part of the y-axis. Which way do we want to shade? We want to go low, right? It's less than. So we're going to shade down here. Okay, and that forms the solution region. Well, the way this one's set up, following the same theme as the rest of them, solving for y has made sense. So if I solve for y here, I'm just going to multiply both sides by 2, right? So y is going to be less than or equal to 2. And I could relate that to slope-intercept form if I want to, but really what kind of line is that? It's horizontal, right? This is a special line. So horizontal line passing through the y-axis at 2, and this one would be solid. Solid because of the equals to aspect. Obviously it passes through here at 2, divides your y-axis up into high part, low part. Since this is less than, we want to shade to the low part, so it would seem to make sense we're shading below the line. Right, there's our solution region. So x is going to be greater than -2. Can't solve for y here, obviously. Just have to recognize this is a special line. This would be a vertical line, right? It's a vertical line that passes through the x-axis at -2. And since there's no equals to aspect, this would be a dashed line. So there's no cutting through the y-axis here to make a high-low right, portion of the y-axis we can relate to. Instead, we just kind of have to use some, I guess you could say, common sense. If x is going to be greater than -2, greater than -2 is going to be all the x values over here, right? It's going to be to the right. So, if I shade everything to the right, that creates my solution region.